Today we are going to discuss proximity sensors. Proximity. It comes under non-contact type sensors. Not to detect the presence and the absence of an object, it does not require any physical contact with the object. That's why we call it a non-contact type sensors. Not to detect the presence and absence of an object, it does not require any physical contact. So that's why non-contact type. We have 5 types of categories under this proximity sensors. First one is inductive proximity sensor. Second one, capacitive proximity sensor. Third one, Hall effect proximity sensor. Fourth one, optical proximity sensor. And finally, ultrasonic proximity sensor or ultrasonic transducer. We call it as ultrasonic transducer. So we have 5 types of proximity sensors: inductive, capacitive, Hall effect, optical proximity, and finally ultrasonic. In the first case, we call it as inductive proximity sensor. Let's see the diagram for a inductive proximity sensor. Here is the diagram for an inductive proximity sensor. In this assembly, we can find there is a mechanism with these 2 sections are called coil assemblies. Coil assembly. There is a internal circuit there not to detect the voltage or current. Here is the flux lines from north to south, magnetic flux lines. Here also is the magnetic flux lines from north to south. By applying some small current to this coil assembly, we get this flux lines, magnetic flux lines. We are utilizing these flux lines to detect the presence of an object. In this case, in inductive proximity, we can only detect the presence and absence of ferromagnetic materials that have magnetic properties. So for example, iron, steel, etc. So only we can detect the presence and absence of iron body or steel body or a ferromagnetic material or ferromagnetic property materials. Here we have the target. Let's see how we detect an inductive or how we detect an object by using an inductive sensor. Let's see. From this coil assembly, we have magnetic flux lines. When the end effector or this sensor close to the target or the object, the magnetic flux lines varies. I will show you. Magnetic flux lines varies when the target close to the sensor, magnetic flux lines will start to flow like this. See. So the entire load of this circuit becomes higher, entire load of the circuit. So the flux lines starts to flow into the ferromagnetic materials. So the inductive current generates. The inductive current generates increases because of the load presence. We call it as eddy current for this inductive generated current. A change in magnetic field can create an electric field. That principle is utilized. A change in magnetic flux lines creates an electric field in the coil that detects, or that is utilized as a presence, used as the presence of an object. Okay. Now we have the second type of proximity sensor, that is capacitive proximity sensor. Capacitive proximity sensor, in which a capacitor is utilized to detect the presence and absence of an object. In the previous class, we have the inductive proximity sensor, in which the inductive technology or induction technology is utilized to detect the presence and absence of an object. In that case, the advantage is we can detect the presence of an object or a target, but the disadvantage is that only ferromagnetic property objects can be detected. In this case, we can detect any type of material, even it is plastic, paper, object, concrete, anything. Any object can be detected by utilizing this capacitive proximity sensor. You can see the diagram of a capacitive proximity sensor, in which you can see there is a PCB. Here we have the components. We arrange a circuit on that PCB. Let it be an oscillator circuit or like that. Any circuit which can detect the change in capacitor. So that we are arranging here. Let's take it's a circuit of an oscillator. Here we have the capacitor. In the front section we have a sensor plate, and the back section we have a reference plate. We know that two parallel plates with a dielectric can form a capacitor, right? So here one plate is movable, little bit movable, and another one is stationary. When we approaches an object, because of the air pressure, the sensitive plate may move a little bit. We have two parallel plates. One is sensor type, another one is stationary or a reference plate. When we approaches a target, because of the air pressure, sensitive plate may vary a little bit. What happens? The distance between the plates may vary. So that will change the capacitance value of the capacitor. Capacitance value of the capacitor. So what happens is, so capacitor value changes when the distance between the parallel plates changes. C is equal to epsilon A by D. When the D, where D is the displacement or distance between the parallel plates, when D changes, the value of C also changes. This capacitor is a part of this oscillatory circuit. Capacitor is a part of this oscillatory circuit. So thereby a change in oscillation occurs. Because of the change in capacitor, the chance of change in oscillation frequency. So thereby we can detect the presence or absence of an object or a target by utilizing a capacitive proximity sensor. The advantage is we can detect any material, plastic, concrete, paper, or even iron, steel, etc. The sensor sensitivity of the sensor is larger when it is close contact with the target. When it is a close contact with the target, the sensitivity increases. And it also varies with the different materials. If you are using a PVC, it should have more close to the material not to detect the capacity change. Or if it is iron body, we get a maximum response or maximum change in capacitance occur. So that's all with the capacitive proximity sensor. Thank you.